Buenos días a todos y a todas y bienvenidos y bienvenidas al tercer y último día de nuestro fabuloso Festival Suratómica, en el cual hemos escuchado todo tipo de procesos de creación y nuevo conocimiento y estoy muy feliz de empezar este tercer día con esta gran charla de una gran artista y amiga, Ulrike Kuchner, a quien voy a presentar ahora en inglés. Y más adelante también conversaremos con ella, con Mónica LoCascio y con Jairo Alexis Rodríguez, así que nos espera una mañana muy interesante. So, welcome Uli, good morning in Bogota and good afternoon for us. Ulrike is an Austrian artist and astronomer. She is also a curator of art and science exhibitions. In astronomy, correct me please if I'm wrong, Uli, you investigate the cosmic web, the properties of galaxies, and you look into models of galaxy formation and evolution and how they change with cosmic time. I hope I said everything correctly. And in art, you are going to talk to us about your artistic work and your artistic processes. And you concentrate now mostly on mistakes, machine mistakes, and turn them into beautiful and amazing, interesting pieces of art. So welcome. I'm super happy to have you here. And yes, thank you.
Thank you very much, Daniela. Thank you so much, Natalia and everyone from Suratómica. I'm really delighted to be part of this festival. I would like to share my screen now and start my presentation. So let me know if this works. Can you see full screen my presentation? Yes, I get a thumbs up. Okay, excellent. And I do need to, this is okay. So I am really sad that we couldn't get together in Bogota and exhibit and talk and basically continue our conversation that we started when we were at CERN together. But I'm so happy that you created this online platform now to celebrate this interconnectedness of art and poetry and politics and protest and science, and really the understanding of what art is and what science is. That's for our convenience only, right? But I want to believe that art or culture and science are two complementary languages of one reality. That's often described in a black and white kind of way, as one being the language of truth, of mathematics, discovery of the fundamental unfeeling and impartial laws of the universe. And these then receive some personal meaning and some individual value through the other language, art and culture. Because emotions really are the bread and butter for art. We respond to it based on our very unique experiences. And importantly, humanity plays a big part in it. So my aim in this talk is to discuss a bit the role of humanity, the empathy in data and science directly, to contemplate on the role of truth and errors in science, as Daniela pointed out, and specifically the science that I do, which is astrophysics, and the art from my personal thoughts and from others that resonate with me. So there will be a little bit of both, of art and science in this talk. And the title of the talk is Do I Dare Disturb the Universe? And this is taken from a famous poem by T.S. Eliot called The Love Song of J. Alfred Prufrock. It's a wonderful poem in its entirety that talks of vanity, a concern of self-image and reputation, very human weaknesses. It's also the title of a piece of artwork that I am slowly working on. Do I dare disturb the universe? And the artwork is based on some work that I did as an astronomer, where I was training a machine to detect something called charge transfer inefficiencies in a telescope that will be launched in a couple of years, hopefully 2022, called the Euclid telescope. It's a European space telescope, very much a successor of the famous Hubble Space Telescope. And you see, a telescope is constantly bombarded with highly energetic radiation, and these over time damage the detectors of the camera on board. And we can model these deteriorations, correct for these failures. And if we didn't correct for them, then over time, every dot, as you can see here on this image, would look like a smeared out teardrop in every stroke. And these are cosmic rays that I simulated here in this image would then become trails, streaks, like you see them here. And so this approach here was using machine learning, so artificial intelligence, which is very much a black box. If I want to link this to yesterday's conversation of Rosa and Paul, that are trained to pick up these deteriorations, or rather to detect values that define these inefficiencies. So these streaks here, this washing out, is the instrument's weakness. It's a sign of aging. And perhaps just like for us humans, we want to get rid of these signs. And in this case, not because of vanity, but because it affects the measurements and ultimately the science that we get. But I want to argue that our weaknesses open up potential to new sensitivity, to empathy, even to new knowledge. The hard science versus this truth that is not so flawless after all. But this fundamental human hunger to know the universe and to make tools that advance our knowledge, that's universal. And it's worth to pause here and ponder how instrumental the instruments actually have been in understanding the universe. And no telescope has really advanced this more and also enchanted us humans than the Hubble Space Telescope, perhaps. It's 30 years old now, believe it or not. And a few years ago, we created this wonderful exhibition, very much in honor of this instrument, that where I was fortunate enough to meet Daniela, because this Hubble Space Telescope has really improved the quality of our understanding. So on the left side of these three images, you can see the same star in all three images. On the left side, it is through a ground-based telescope. So you see how the resolution, and linking this again to Rosa's talk yesterday, is very different to what we know from something like the Hubble. And in the middle, you see how the first images of Hubble came back. They were actually grainy and fuzzy and deeply disappointing because due to some oversight during the fabrication, the mirror of the primary mirror of the Hubble Space Telescope was too shallow by like 2 microns, so a tiny fraction of a human hair. There were some wrong specifications, and this caused some spherical aberration. That means this mistake prevented the telescope from focusing the lights properly. And so as a result, the starlight was not brought to focus, but had these blurry images with these huge wings that you can see in the middle. On the right-hand side, you can see the same star after the correction of the mirror. And below it, I typed up a poem by Rebecca Elson, who was a Canadian astronomer, died way too young. She was the first named author of a major review article on star clusters, and then took up a fellowship to teach creative writing. So she was very much a cross-pollinator. She then had a stint teaching Harvard writing course and science and ethics, but was an astrophysicist. And she wrote this poem about this blurry first images. The way they tell it, all the stars have wings, the sky so full of wings, there is no sky. And just for a moment, you forget the era and the crimped paths of light, and you see it, the immense migration, and you hear the rush, the beating, connecting this perhaps to a flock of birds taking flight. She also wrote in a poem called We Astronomers that we have to honor our responsibility to awe. And I believe that images are really incremental for that. It's much easier to explain the questions and why questions matter with images that fascinate. Like this one here, images like these. So this is a galaxy that has a colliding, interacting galaxy. And they, for me, were really, really important on my path to becoming an astronomer. And most of us really go into science or astronomy because they are captivated by it, by perhaps some would say the beauty of it, some kind of awe. And after several service missions and upgrades, then the telescope managed to get these data. So this image shows how highly disturbed the galaxy is just after some major interaction with another galaxy. And all the other blobs that you can see in this image are other galaxies. So the main one that you see here in the center, I don't know, I can highlight some things. Yeah, here you see gas and dust being pushed out by the gravitational pull of another galaxy. You see new stars being formed in the tail of this galaxy. And every other dot here, are other external galaxies, except for a few stars. Here's a star, here's another one. And this, seeing these images in the first year of my studies, they were the reason why I wanted to study galaxies. This is a simulation that briefly shows from a computer model how this interaction works. So also to give you a bit the background, you have these two galaxies and two gravitational fields of these galaxies, and they come closer and they result in these disturbances. Here you see the computer simulation that has some realistic physical principles inserted, so gravitational forces, gas dissipation, star formation, recipes, and then you let it run and see what happens here. Look at this dance, and then this video pauses and shows you some real images, so it contrasts simulations with some observations. And the problem with most physics books is that they tell you the answers, but they don't explain the questions. Margaret Wertheim said that. So a fundamental question is, what is the future of our own galaxy? And seeing this, this could be where we're going. You know, not exactly this, but our own Milky Way galaxy will collide with the Andromeda galaxy, and we will have some of these fantastic collisions. This will happen in billions of years, so don't panic. So relevant to this conversation is this notion of truth and errors. Even the best of images don't arrive to us like that. We need to clean them and calibrate the data, no matter which instrument they come from. And to create an image like this, the data accumulated through the observation actually first looks like this. So it's a noisy, dirty image. We call it raw images. It's actually a lot of images that are added up then. And the challenge is to remove the noise, to improve the resolution, to deliver a more accurate version of it. We need to understand the imperfections, to clean it, and remove these instrumental errors. And they are due to conditions that aren't perfect, because nature is not perfect. And to calibrate it, remove these unwanted parts. So there are tools in science, a step to get you to the final image. And I find this very interesting, that camera chips are not objective observers either. They have their own individuality. They have flaws in the pixels, patterns in the response across the chip. And even if we take an image of darkness, it's not dark. You just see the way the chip is before any light hits it. It's a picture of the camera itself. A bias frame, like this example here, is an image obtained from the image sensor without an exposure, so it's 0-second exposure, and you still see some dead pixel rows here, another pixel, depending on how well calibrated your screen is, you will see some inconsistencies here. And I was really interested in this, and several years ago I was working on cleaning some observations of galaxy spectra for my master's in astronomy. And also I used these then for my diploma in art, which I was fortunate enough to do at the same time. So I started using these calibration images in their own right. And very interesting to me is this question: when does a bug become a feature? So out of these investigations, and here you see some experiments really of using some of these calibration data that I was working with in a printing lab, a printing studio in our art university. And they became a piece of work that I've been working on then for years, called Measuring Mistakes. I wanted to highlight these unwanted parts in the data, these natural annoyances, these uncomfortable tools of science, of this making mistake. And they grew and became a really big part of my artistic endeavor. And I love how people react to them and how they can see, even if they don't know what it is, see some of these mistakes and errors in them and can relate to it, because it's a very human thing to not be perfect, and you're drawn to finding the imperfections in the image. The way that all of this was then delivered in science is a very stripped down, sobering way. So here is this screenshot of a paper then that used these spectra in a publication. So scientific knowledge aims to be objective, independent of the human, cultural or personal background of the scholar. It's also rarely political, so it tries to be stripped away from all of these emotions. Again, I print a little piece of Rebecca Elson's poem here, which basically says at the very end, "And I forgot to ask the questions and only count things." So this is a danger for all of us. As you can tell, I'm still interested in this topic, so much that Daniela asked me to talk about it. For one, because these calibration images are invisible images, not impossible, like Rosa is working on, but invisible to the end result. But they cost a lot of money to produce, and then they're usually thrown away, never to be seen, really. This step is barely mentioned in the publication. And in fact, in many telescopes already, and more in the future, the science images will be reduced and calibrated without the scientists steering. Some pipeline will do the job for them. And the raw image and calibration data will not even be stored. So it's gone. This piece is called Data with Empathy. I'm also sitting in front of them. And here I mixed intentional human errors, my own errors, with errors of the machine. So I used raw images, so unprocessed exposures of the Cassini spacecraft from a fly-through Saturn's ring. And so in a world where we're training the machines to be flawless, to precisely predict our next step, I want to showcase the human learning process through making original mistakes, brilliant mistakes, and alluding to this paradox of our culture's fear of being wrong and making mistakes. So this Data with Empathy is very much a celebration of mistakes. I enjoyed doing them, and it's in the silkscreen printing studio. And the only opportunity for learning or making something truly new is making mistakes. Daniel Dennett said that. And space exploration. So this image is using data from the Cassini space mission. That's really the pinnacle of a journey of historical risk takings and learning from mistakes and the mess that humans can make. It was a beautiful exhibition where I invited people to walk around and see and look at everything that could go wrong, but definitely did go wrong. But here's the pure, beautiful image from the Cassini spacecraft mission. So to pause and introduce myself at a very late stage in this talk, I am a research fellow currently in astronomy in the University of Nottingham in the UK. I moved here after my PhD. As Daniela said, I study how galaxies evolve in the context of the large-scale structure, the environment of the galaxies, and together with some amazing people here, I observe and model the largest scales in the universe, the filamentary structure of this cosmic web, and that is how matter is organized in the universe. So that's my day job. I spend most of my time doing that. I was very lucky that I was also able to study art sort of at the same time. Definitely not a linear path, but I had a hard time choosing what I want to be when I grow up. And I grew up in a country where it was possible to try both and had the background from my family to allow to do both. And astronomy is really pretty amazing in the sense that it has the ability to inspire people. Young people just starting out their lives, people from all walks of life have the opportunity to leave behind for a moment their personal turmoils, the political chaos that surrounds them when they look up into the night sky and see the stars, and perhaps even have a chance to go look through a telescope to see even further out, realize what made us, what made everything they know, these impartial stars, and then look back in with a widened view, maybe a recalibrated perspective. This is and was the main driver for me to get interested in astronomy and to express that in some way through art as well. This image was taken by a friend, Juan Carlos Munoz, who was an ESO fellow. He was working in Chile in the Atacama Desert, and the image earlier that you saw was me standing in front of the very large telescope, one of the happier moments in my astronomy career. That is really breathtaking. And below was in my studio working on the measuring mistakes. So what brought me there? A few things stand out. Visiting a large observatory as a young teenager with my family, that's definitely a standout moment. I basically soaked up the outreach material that they sold in their gift shop. And then a few years later, an accident of our solar system, a total solar eclipse. So this image was not taken by me. You see the credits here at the bottom, but I was with friends at a lake, and during the time of totality, we jumped into the lake and just time paused. It was absolutely breathtaking. And why an accident, an absurd accident of our circumstances, as Jenna Levin calls it? Well, you know, the sun is bright in the sky. The moon, this silly little rock, is just the right apparent size to cover it completely. They're of course not the same physical size, but the moon is 400 the size of the sun, and the sun is 400 times further away. And that gives rise to these rare moments of pure magic. These, when they align, this total solar eclipse. If you have not seen one, if you can, I urge you to make an effort to see one. It's absolutely pause-giving. It definitely recalibrated my life a few times now. And eclipses are, of course, also very crucial in the formation of modern science. It was an eclipse 101 years ago, that was needed to prove Einstein's theory of relativity. 100 years ago, 101, in 1919, Eddington set out to verify this theory, arguably one of humanity's greatest achievements, where they wanted to measure a star that is behind the sun and is deflected by the sun's gravity and mass. The deflections that they measured on this A4 paper were tiny, 1/40th of a millimeter. So this image on the left, you're supposed to see some dots between the lines. In truth, this was extremely hard to achieve. Eddington's data was highly flawed. And there was public acclaim, but many scientists were suspicious of his claims to have a proven relativity. It did not help that Einstein was German, and Germany had just lost the war. 1919 eclipse results just did not stand up to modern standards of proof, because Eddington's team was hoping to see a little moving of the stars when they compared two different images, but some of those went in the wrong direction. So it was very flawed, so much so that a few years later, another party had to remake this experiment in Australia. A party of 30 scientists and their wives went out to do that. And then in 1923, they could confirm Einstein's predictions. But that is a bit washed out of the story. What we remember is that in 1919, the British astronomer Royal announced the results, that it did not support Newton's theory of gravity. They confirmed Einstein's predictions, and the messages here, you see that on the left, they were basically, Newton was wrong, Einstein is a genius, ordinary people cannot understand it. But the story just ran around the world, just pushed these men to fame. And we know Eddington was this Quaker pacifist internationalist, much celebrated last year at the 100th anniversary. But what I recently learned when I listened to a talk by Jenna Levin is that he very much was a human being with human flaws. He had a famous and brutal rivalry with another astrophysicist, the Indian Chandrasekhar, who was quite beloved and is important in his own right. And Eddington invited Chandrasekhar to present a theory about the death of stars. There's this Chandrasekhar limit above with which stars, when they die, become black holes. So he presented this, and Eddington tore him down immediately afterwards. So we have this inflicting reality here. Eddington, the transcendent internationalist, this great man of science, and Eddington, who takes down Chandrasekhar, an outsider, an immigrant. So surely morality lags behind technology and genetic engineering and AI. We're nowhere close to answering moral questions, and great men and women think about these. I'm not the first to mention this. But to me, our definitions of success and our aversions to failure make science so deeply human. So how does this influence how we see the science? Does it even play a role? It was still a triumph to prove the theory. It's the same phenomenon that lenses galaxies, as you can see on the left. It's also the same phenomenon that was used to lens the black hole that you see on the right. That was published last year using this Event Horizon Telescope, which is a collaboration of many different telescopes. And the scientists obtained an image of the black hole at the center of the galaxy. And what you can see here actually is the black hole outlined by the emission of hot gas swirling around it and behind it. The light bends under the influence of the strong gravity, just as in the image on the left and in what Eddington tried to measure. So you also see this in this image of a galaxy cluster. This is more my area of expertise now. I'm trained in scientific methods to make sense of the universe. The universe is under no obligation to make sense to me. The classical view of science assumes that the facts speaks for themselves. And will therefore be interpreted by all citizens in the same way. But really the idea that we can stand back and behold nature at a distance as something discrete from our own actions, and that is an illusion. Philosopher Bruno Latour said this. And he also argued, and we just went through an example of this, that scientific facts are products of scientific inquiry. We interpret and judge them according to our professional training. They stand out or fall with the institution and practices that produce them. And science is the result of messy debates. So for some, this might be more the image on the left and the papers that get along with that. For others, like for Monica LoCascio, who will join our discussion afterwards, it's the image on the right. So this is an artistic response to the same kind of images, to the same questions of these large-scale structure of galaxy clusters. So if scientific knowledge is socially produced, as we just argued, is it not fallible? And the last decade has really seen a rise in anti-scientific thinking. So I wonder, can art and science here conspire to have people in this post-truth era believe in facts and in the humanity? Can we approach science from a position of wonder? And I saw many people walking around Monica's piece and showed that. Will science ever discover humanity? Is a big question for me. And one way is this telescopic view that I was mentioning, this way to get a moment of calm when you realize that everything is really big, and that just a friendly reminder that we are a tiny, tiny fraction of normal matter, and most of it is is not something that we can see or comprehend really. This here is a simulation from the cosmic web, and it kind of links the images that I showed before. All of these galaxy clusters where many galaxies come together are linked again by these bridges and filaments of matter, baryonic matter and dark matter. On the left-hand side, you see again a visualization of this topology of the cosmic web. And on the right-hand side, you see Thomas Saraceno's response to that, the spider web. And so art science is not a science visualization. It's not supposed to be illustrative. It allows people to sense this awe and to have the emotions. For scientists, how can we project the science so that it has some true meaning? And art may play a major role here. Science can be calming and give us some perspective. Everything there forces you to think big. We have these decadal reviews where scientists come together and talk and propose strategic plans that stretch out the next decades into the future, where lots of trends come and go. But there is also a bit of a danger to get lost in this and lose a bit this urgency of the here and now. And art has the ability to pull us back and emphasize this, in my opinion. So I value this opposition, but there is a certain irony for looking for life and for the big picture and for other galaxies, while compromising and destroying our own lives here. That is a common struggle, I think. But to talk a bit more about this big picture, this is a video simulation that just uses dark matter. You see in the top left time as we measure it in redshifts, evolving from the beginning of the universe to the present day. And you see here how this large-scale structure, the spider web, evolves. So the overdensities grow by gravity, and the denser regions become more dense, and the voids, so here in blue, become emptier and emptier. So this was, almost 14 billion years, showing you in a few seconds of how we believe the universe evolved. These are computer simulations by it's almost 20 years old now, I think. It's hard to imagine. So that was time, and this is space. So this here zooms into the nodes of this cosmic web, or the densest points. These are the galaxy clusters that we've seen in several images before. So you see how all of these dense points are connected by the filaments. And this is where most of the matter in our universe resides. So this is my current area of work. Again, these are computer simulations. In the end, mostly you see papers like these, where you share your results with the community and get criticized by it and get responses to it. And one response to it is again an artistic piece. So this is called The Reference Truth that I'm working on. And I would like to end my presentation again with some lines from the T.S. Eliot poem that where I took also the title of this talk. And it says, "Would it have been worthwhile to have bitten off the matter with a smile, to have squeezed the universe into a ball, to roll it forward, some overwhelming question. We do not ask, what is it? Let us go and make our visit. So thank you very much.
Uli, thank you very, very much for your talk. Every time I hear you talk about what you do in astronomy, I get the feeling that that's what I want to know. And personally, you have been a big influence and inspiration for me in everything I do artistically. And I'm also extremely glad that you are part of Suratómica. Here I want to say that you have been part of Suratómica from the beginning, because when you and me first started working together, Suratómica didn't exist. But it was because also of the input of the exhibition we did together that this idea happened, and this like we want to work with the whole globe. We want to work with everybody and connect ideas. So this connects actually to your cosmic web, like the way we are connecting network-based everything on the planet. So first, let me say thank you for being part of this. And I want to ask you a question that I have been thinking about for some time now, because you talk about the magnificence of the universe and how you saw it, and I feel what you're feeling when you talk about it, when you talk about the eclipse and everything. Mm-hmm. Or when you talk about the ALMA telescope and seeing it with your own eyes. Some time ago, you told me the difference of being in the astronomy, your astronomy work, like working with the numbers and algorithms and screens. And then you go to your artistic laboratory and you work with the paint and the ink and the paper, and you get. So I have two questions regarding that. The first would be if you find it. I mean, if you have this feeling of awe while also looking at the numbers, because numbers have also this deepness, and if you know that they are connected to the universe and to the stars and to the filaments and everything, do you have this feeling? And second would be like, how do you connect these two spaces? And if you connect them, I mean, I see that you connect them, at least in the poetry that you read, because it's there. But how do you feel about these two spaces?
Right. So the numbers question, it is overwhelming to begin with to read numbers, that are unimaginable, or to connect those to distances or times. People say, oh, this is so far away, I cannot imagine, or this is so big, I cannot imagine. Weirdly, you get used to it. So it's possible to train yourself not to be in awe of big numbers anymore. But I remember that very early in my art uni program, I was struggling with how to express this this dichotomy, I guess, between feeling incredibly small when looking at these things, and insignificant, and at the same time, the most important person in myself and to myself. And one way of expressing that was by starting to count and just never end. And it was very liberating to just write numbers and count. I mean, this was the artistic side of it, to try to wrap my head around what very, very, very big numbers mean. While I'm showing this picture again. So these blobs, don't know why my cursor is gone. These blobs on the side here are our neighboring galaxies. They are the Magellanic Clouds here. The large and small Magellanic Clouds. You can see them from the southern hemisphere. It just, when I first saw them, I thought they're falling down on me. I couldn't believe it. They're so big. It was just absolutely fantastic. It's just also here in the southern hemisphere. So this picture was taken in Chile. You can look into the center of our own galaxy. It's just unbelievable. So in the same way, numbers frighten me. I'm not a very good mathematician, and that, of course, is a problem. But so I have this, I love them and I am afraid of them feeling when it comes to numbers that are connected to maths. The second part of your question about connecting art and science. So that has, there's a big evolution in my life, because in the beginning, as I said, I studied art and science simultaneously in 2 different universities, which you can do in Austria. Also, it's free. I wanted to separate these 2 things. So I thought I could do half of the week just attending those courses and the other half just attending the other courses and not get them confused. But that confused me a lot. And after some time, it became very clear that that I need to connect these 2 things. That is an ongoing work and struggle. For me, it makes, inside me, it makes more sense now to try to connect these 2 communities that each have their own way of communicating, of expression, of presenting their thoughts is more difficult for me. I do enjoy trying to translate, to have people from these 2 different communities communicate, but it is not easy. Not an easy task. Did that answer your question, Daniela?
Yes. I can completely imagine it. I mean, if I had a scientific laboratory and then an artistic workshop, I think I would be like these 2. Like, how do I bring these 2 like physical spaces together in my head?
Yes, well, often it's finding a common denominator, finding something that both parties agree on, and that is very often the passion for their subject and the sense of awe. So if you start at that level and then break it down and go step by step, then I think it works. But if you find something in common, that's the way in, I think.
That's beautiful. So for the last 5 minutes, I would like to know how your experience was curating this amazing Hubble Space Telescope exhibition, where you had a group of artists that didn't know anything about this. I mean, we knew somehow, like the pictures, and we read some things. But how was it for you to to connect these artistic ideas with your scientific knowledge in this curating?
Well, I learned a lot. It was a learning by doing experience. Because on the one hand, it was this very creative, especially the more junior, the younger students that were making original work for this exhibition, totally immersed in their creative endeavors. And on the other hand, the organizers from ESA, very institutional scientific people, and then the museum and this organization in itself. So there's a lot of project management skills, I guess, that helped. But because I know that, if I may say, I'm part of the science group, and I'm part of the art group, I knew how to talk and to translate. I'm by no means the only person who can do that, but it helped me to have been immersed in both, and to know how to approach both. I hope that it worked out. I am so proud of the result. I think it stood out and it was fantastic, and I got some really good feedback to how we made it possible to bring both the arts and sciences to the same level, and not have art explain a scientific concept or visualize the science or be a little sidekick to it, whereas the art used and really milked the science and also the institution of how science is made, so that we have very varied art pieces in this exhibition. It was called Our Place in Space. Yeah.
Yes, I also think that it was a very good show about these two languages converging, if you can say it like that. Yeah. So yes, and I now we only have 3 minutes left, and I just wanted to say that you were also part of our residency at CERN, and that it was, I mean, also there seeing you at CERN and being with us. We were a group of Colombian artists and creators and dancers and everything, that there is a tool that you manage, and it is the language tool of both worlds. And I think this is something that shows in every aspect of you, like in in this, like the presentation aspect or artistic aspect. And even if I have never read a text, an astronomy text of you, I'm sure that it shows. Somehow it shows there as well.
I hope so. I hope so. And I do hear that it does a bit. No, that CERN residency was such a pleasure. I really loved the energy that the artists had. They wanted to soak up everything, and it was, I'm really glad that I could help explain things and have an objective view. Yeah,
it was great. Great to have you there. Yes, it was really, really good that you could join us. And maybe for the next one, I mean, you are always welcome in every Suratómica space. And of course, we want to have you in Colombia when we do the exhibition. And I am really looking forward for the work you are creating for this Suratómica exhibition. So, well, in the next 10 minutes, we will be talking to Monica, who is the artist, one of the artists of the show you curated, and to Jairo Alexis Rodríguez, a professor and physicist from Bogota. So everybody who's watching, stay tuned. We will do a short break and come back in a couple of minutes. Thank you, Uli.
Thank you.